Hello and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I am your host, John Sheff, Danfoss's Director of Public and Industry Affairs. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. Today, we are thrilled to have Ted Wilke of SPOC Automation back with us for a second time, and he's joined by Andrew Williams, who is the managing director of the newly created SPOC Grid Inverter Technologies. And we're going to be discussing the impact of ESG reporting, or environmental, social, and governance reporting, on efficient industrial operations. Really important topic, a topic that's coming up more and more for me in my work every day. So Ted, welcome back to the show. Andrew, thanks for joining us for the first time. Please introduce yourselves and tell us a little bit about your roles at SPOC.
Thank you, John. I'm glad to be back. I appreciate the opportunity. I hope the listeners get something out of this podcast today. At SPOC Automation, we are a 20-year-old company. I'm the vice president of the company. We're actually a family of companies. One group is focused on traditional electrical infrastructure, running electrical motors. And then Andrew is our managing director of our new grid business, which works on hybridization solutions, as well as helping people optimize their generator applications. So I'll let Andrew take this one.
Andrew Williams. I've been in the switchgear and power control business for about 30 years now. And what we're focused on at SPOC Grid Inverter Technologies is really the next generations of power systems. And when we say the next generation, what we're talking about is the ability to integrate all of the renewable sources of energy, as well as energy storage, with the traditional sources.
So ESG is becoming an increasingly important part of really large businesses and how they operate, being asked to report the environmental, social, and governmental impacts of their business. But for a business like yours, and for Danfoss also, explain ESG and why we're discussing it in the context of industrial operations and why it's important.
Yeah, absolutely. It sounds kind of complex. Environmental, social, and governance criteria. They're a set of standards for a company's operations, and socially conscious investors use them to screen their investments. Environmental, which we're going to spend most of our time today talking about, our environmental criteria consider how a company performs as a steward of nature. Social criteria examines how it manages relationships with employees, suppliers, customers, and the communities. Then governance, of course, deals with leadership, executive pay, audits, controls, and things like that. So if that sounds really complex, let's boil it down to the simple fact. Institutional investors are using ESG goals and results in making decisions on where to invest their capital. If an organization doesn't have a story about how they're treating their people, minimizing the impact of their operations to the environment, and how they're working to make sure they obey the laws and safeguard investor interests, they will be starved of capital. Add this to the background of the fact that industry uses a majority of electrical power in the U.S., and you can see why ESG is really, really important to the industrial business in the United States.
Yeah, and I think that using less power and optimizing your efficiency, it's just good business sense, but it also is good for the investors and good for them to know what's going on. And I don't think that investors are willing to accept maximizing shareholder value as just kind of the bottom line for any company. So I think a few years ago, this may be on the fringe, but like I said, I think it's really coming into the mainstream right now. Why do you think that is? Why is it becoming so important at this moment?
Well, I think there's a whole bunch of reasons for that, John. From a capital standpoint, banks have opinions. Investors have an opinion. So you look at pension funds. Pension funds are making decisions on where they invest their money, where they invest those pension funds that they have. And the capital sources for organizations, their very lifeblood of business is injections of capital when they're needed, whether that be in securities market or within the bonds and issuances of capital to those companies. If they can't do it right, they're going to be starved of capital. They can't get the right rates, and they're not going to be successful compared to their peers.
Yeah, I think that's really important, that it's really being driven by the investors now. And that's why you're seeing all these companies really infusing it into their business. And instead of being a cost center, I think it really is being infused into the core of companies' businesses right now. So I think that's why you're seeing this kind of change. You're absolutely right. But getting back, let's focus on the environmental, because it's kind of what we're here to talk about. How is SPOC really contributing? Andrew, how's SPOC Grid Inverter Technologies contributing to a company's environmental goals?
So what SPOC Grid is doing is we're really focused on helping companies with on-site power generation facilities reduce their fuel consumption. And that fits into what's considered a Scope 1 criteria, where Scope 2 would be power purchased from the grid. SPOC automation has a long history of helping companies reduce their Scope 2 emissions. SPOC Grid is now focused on the power generation side.
I mean, and so interesting because, obviously becoming as efficient as possible as for an industrial company, saving money contributes to the bottom line. But are you seeing new business from companies who are specifically asking you to help you with their Scope 1 emissions?
We are. And the first place we're seeing it is in the marine industry. And the marine industry is unique. As you guys know, Danfoss has a long history in the industry. And we saw it out of a lot of the innovators in Europe in taking diesel generators and slowing those diesel generators down when they're not under heavy load. And they were able to see in excess of 30% fuel savings in some cases. And taking a look at the way that they set their systems up, we knew there was room for improvement to be able to take that same technology, the same ideas, the same concepts, and do things such as add energy storage and variable frequency generation to other applications other than marine.
Yeah, I think it's so interesting that you mentioned diesel because, we don't normally think about diesel operations or oil and gas when we talk about the E and ESG. People automatically go to renewables or go to, electrification. But I think there's such a huge part to play in making oil and gas operations more efficient and making marine operations that use diesel more efficient. You guys are heavily involved in that, right?
We are. So diesel and natural gas both are used in many, many different phases of oil and gas production. So we think about the drilling. You're not going to bring in a 5,000 amp electrical service to a drilling rig and then after 20 days abandon that service. You're going to have a temporary power generation, usually uses diesel. Some companies are looking at using natural gas for that. From there, you talk about the high pressure pumping, the hydraulic fracturing that we all know about. That usually, again, is fueled by diesel. Oftentimes, when it comes to producing the well after it's completed, the electrical utility isn't there yet. The oil companies move faster than the utility does, and that probably doesn't surprise us. Utilities are large organizations. They're spread very thin. They're not set up to go ahead and put in 100 large electrical services a week, whereas oil and gas companies as a collective group can. So we see really on-site generation used in every aspect of the business that is temporary. And even some that are more permanent, we see them initially, in a transient way. So there are huge opportunities for companies to really reduce their fuel usage, saving them money, helping them meet their Scope 1 objectives by using the SPOC Grid technologies.
Yeah, and Ted and I have talked about offline, this idea of off-grid technologies and making them as efficient as possible. I think we could do a whole show about that. But I don't think people realize how important it is, even in oil and gas operations, those companies have ESG obligations too, and they're trying to meet them too, right?
They are. All of our customers have ESG objectives. We looked across the marketplace and 93% of the large independent oil and gas companies have published ESG objectives. 100% of the integrated majors. We think of the integrated majors, people like the Exxons and BPs of the world that we all are household names because that's where we get gasoline for our car when we go fill up. Within even the small and mid-size independents in the United States, 2/3 of them have ESG objectives. So really, this is not a big company thing. It's not a them and us thing. It's not a some and not many thing. It's really almost all of the oil and gas producers in America have ESG objectives, and they're trying to find ways to operate more efficiently, more economically, more profitably, and then, of course, meeting the requirements that society at large and the investment community has for them.
And I think one of the cool things about the technologies that you guys use that Danfoss manufactures also is the amount of data that's spit out. I think that people were obviously still initially and still using this data in their operations, but this can all be used in the reporting too, right?
It can, from both the production side as well as in the generation side. It's a neat part of digitalization. We take processes that we used to really not instrument in a way and store data and trend data in a way that we do today. Today, we can use that data not just to make the operations more efficient, but also in reporting that is factual, timely, and archivable and retrievable so that you can do something with it. If you can't do those things, it's really not actionable data. So that's one of the reasons SPOC has a third company, SCADA, which we're not really going to talk about today. But we think that data reporting, digitalization piece of industry is incredibly important.
Now, on this show, we talk a lot about electrification in terms of buildings, transport. We don't necessarily talk about electrification in terms of the oil and gas industry. But like we mentioned, I think making those operations as efficient as possible is really important. Ted, Andrew, tell us about what it means to electrify the oil and gas industry and how they're saving energy and money.
On the production side of the business, it's obviously not practical to make a stark choice between if we can't electrify, we won't do it. That's just not practical. Investors they have ESG requirements, but they also have profitability requirements. And money may not be the reason that a company's in business, but you do need money to be in business. That's just a requirement. It's like blood is for a human. So we want to electrify. Our customers want to electrify. There are many, many reasons. And candidly, return on investment is a big one. We've had customers tell us that when they run diesel to power an operation instead of using grid electricity, those costs are triple. So they have 3 times the operating cost for fuel than they would if they were simply buying kilowatt hours from the utility. That's a pretty big incentive. Add in the fact that, of course, Scope 1 is the most important measurement that the oil and gas companies have right now for a number of different reasons. Scope 1 for oil and gas looks like flare gas, diesel burned, natural gas burned. And there are lots of different places where they're doing that. They want to find ways to reduce that. It's their biggest opportunity that they have. So we think that they do want to electrify. And the number one reason is obviously cost. But the number 2 is ESG. And I don't think those are on the opposite sides of the coin. I think those really go hand in hand together.
Yeah, I think so. I mean, I think that's really what we're talking about here, is that these are not two discrete things, is that a lot of the things that companies are doing already to decrease their operating costs are important for ESG and particularly the E. Now, let's talk a little bit about hybridization. I mean, this is a technology, at least I think in the mainstream, is not well understood, but explain what that means in this context.
So think about it in terms of how hybrid cars work today. So hybrid cars take a gasoline engine and use them in conjunction with an electric motor to make the vehicle operate more efficiently. So what we're proposing to do is a very similar concept for on-site power generation. And it's really important because if you look at the way that generators are sized, so when someone takes their load profile and takes a look at what kind of loads from a total power used, the type of loads and starting requirements for large motors, they normally are going to have a much larger generator than what's required to operate their base loads or what they would typically see, simply because they can't afford to buy something that's too small and not have their most critical load be able to start. So when we look at the Danfoss technology that helps to enable that, an active front end takes your power factor the generator sees and can elevate that all the way to a perfect 1.0. Can take your harmonics and with some filtering and get that down below 3%. It's going to allow your generator to operate with a higher degree of electrical efficiency. That power is then selectively taken and stored onto the DC bus, where we're going to use our expertise to help size energy storage systems to put on that DC bus that can then be delivered out through a grid inverter down to the load side. And when you look at the ways that generators deal with loads, when generators are loaded to 80% of capacity, they burn the fuel cleanly, carbon stacking, and your energy usage, your fuel usage is actually lower per kilowatt hour than if that same genset was very lightly loaded. So what we're talking about is the ability of the end user to reduce their upfront capital expenditure by potentially buying a much smaller genset, reducing their operating costs by burning less fuel the entire time they're using it, and reducing their emissions because they are burning less fuel. One of the other big benefits is from a safety perspective, and I think this does get overlooked, because an inverter is able to closely regulate both the amplitude and the direction of current. Were there to be an incident downstream, the inverter can detect that in less than a millisecond and then determine what to do. So we're going to be greatly reducing the amount of incident energy that's delivered downstream, creating a safer environment for humans to work in, as well as a much better chance that if there is an incident downstream, that downstream equipment can survive and be quickly put back into commission again. Then looking back upstream, because your generator is isolated through an inverter, your generator never sees a system fault. It's just another added benefit. And if you do happen to want to add any of the renewable sources online, having that common DC bus is a great and easy place to do it. That energy storage system is also going to give you an excellent demand response. That DC bus is all about kW. You're not worried about power factor or anything else. So you're going to be able to instantly have a great way to regulate both your voltage and current on your job site. Not to mention, if your primary source of power goes down, you also have depending on how we size it, have an emergency power source. So the ability to have a built-in backup on site, I know, is important as well. So overall efficiency, safety, flexibility, performance, and reliability, I think that's what the industry is asking for. And that's why we think it's time, for people to really take a hard look at how they're configuring their on-site power systems.
I think this is such cool technology and really important technology. People all automatically want to jump to electrification, decarbonization, but that's not always possible. And particularly in a retrofit scenario, right? These systems can be used as opposed to what would be a huge expense of trying to retrofit an existing diesel system for fully electric capabilities.
Yeah, it's a great way for a company to reduce their emissions without having to go through what I would almost consider to be a duplicate capital investment, which really wouldn't make any sense. We see that about a third of our customers on the production side in the oil business on new wells are utilizing diesel or natural gas as their fuel source instead of electric utility. For those customers that the electric utility hasn't brought wires and lines and transformers and power out to them, this is a great way for them to reduce their fuel consumption, be environmentally conscious, and increase their profitability all at the same time.
Yeah, I think this hybrid technology really, really has a place as we kind of go forward and look for ways to save emissions, but also just to be more efficient and to save on fuel costs. What did you mention? Reducing your fuel costs by a third if you're using all diesel going to one of these systems, or by 2/3 going down to a third of the existing cost.
That's right. So when we talk about putting a grid inverter, we should typically see savings between 10 and 20%. A big savings. We certainly would love to see the full electric solution with a savings of 66% or 2/3. But, if there's no electric utility, that's a false choice. We can't use what isn't there. So I think the grid inverter technology really does help kind of bridge that gap and say, hey, there's a better way to do it. We eventually want to be on the electric grid and get a bigger savings, but a 10 to 20% reduction in emissions is fantastic. If every industry could find a way to do that, I think that we'd all be having different discussions about some things.
And yeah, just in terms of reducing your operating costs, for some of these oil and gas companies where their operating margin, their profit margin is really dependent on the price of oil, as it goes up and down, that 10 or 20% can be a huge thing and be the difference between keeping the operation going or having to shut it down, right?
It's a huge impact. And what's just as big of an impact that we overlook, that access to low cost capital. If you're an organization that doesn't have strong ESG objectives and you're going out and shopping for capital, your cost of capital is going to be higher than your peer companies that do have strong ESG objectives. So in this particular instance, it's one of those strange things where the impact is actually magnified and amplified. If your cost of capital is 1% higher and you're taking $1 billion loan to develop a field, it's a huge annual expense, that interest carrying cost to do that. So add in the 10 to 20% savings on fuel costs, and it's a massive savings. We're seeing the market reward people that are doing the right thing. And that doesn't surprise me. The market does usually find those ways to reward those people that are running efficiently and better.
And I think that's why we're ultimately talking about this right now and talking about ESG, is because it is tied to access to capital. It is tied to capital markets. And that's why people are paying attention. That's what's driving this change. And I think you're right. People are making changes for the better, running more efficiently, saving money, and also producing less emissions. Finally, as we kind of wrap up here, how do you see ESG and this concept going in the future? How is it going to evolve? But where do you see it ending up in 10 years in your customers' operations?
There's a huge drive right now to figure out how to stop emitting carbon and other types of gases into the environment that people see as being harmful. So I think it's going to drive huge changes in technology. We've already seen major engine manufacturers announce that they're going to start producing engines that run purely on hydrogen. And while we can sit here and dispute whether or not that's the right technology, to even think there was going to be an announcement like that 10 years ago wasn't in the cards, in my opinion. So what we're trying to do is position ourselves and help position our clients so that whatever the next generation of technology is that helps reduce those emissions, and whatever that source of power is ultimately, and whatever that energy storage medium is, the idea that you're going to be able to just have circuit breakers that were basically invented in 1879 and still work exactly the same way. It's probably going to be the next generation of inverters that replaces what we know today as switchgear, because I do think it's critical to be able to control all these different sources of power very tightly in order to get the right kind of results. The last thing anybody wants to do is see grids become less stable because you've got too many sources of different kinds of power, right? All of this needs to, as it moves forward, be controlled, and the right type of infrastructures need to be put together. And I think we're right on the cusp of having all of that technology available that can help not just with tomorrow's sources of energy, but we can actually help with today's sources of energy while making it easier to integrate future sources of energy and energy storage into our grid and make it available for local usage and make it more reliable at the same time.
Yeah, and John, if I could add, I think that the idea of social capital and legislative pressures, will they increase or decrease? I think that the obvious answer is we're going to see more pressure on innovation, on manufacturing, on society, on industry, on really every facet of our lives to be doing things more efficiently. I think it's a pretty low risk statement to say that this is really the beginning of a trend and not the end. I truly believe we're on just the beginning portion of this wave. I think in 10 years, the ESG reporting will be more standardized and easier to interpret. And I think that'll be a benefit. I think it's going to help communities and investors and governments understand really what companies and organizations and manufacturers are doing. And I think that, as Andrew says, it's really going to drive massive technological shifts that we really haven't seen in industry since electrification began 100 years ago, or over 100 years ago, really. So it's a pretty exciting time to be in this industry. Perhaps we're not as fun and exciting as an electric car, perhaps, but I think that the magnitude of what's actually happening is far greater. So that's kind of a neat idea for us.
Yeah, I think that you guys at SPOC in general is just incredibly well positioned. And, I would actually like to come back. Maybe we can do another show just about inverter technology and power electronics, and that idea that Andrew mentioned of trying to weave together all these different sources of power that are coming in, AC and DC, and how it all converges, I think could be a really interesting show. But I want to thank you guys, Andrew Williams of SPOC Grid Inverter Technology and Ted Wilke of SPOC Automation. Thank you guys. This was a really interesting discussion. Like you said, one that we're just at the beginning of.
Thank you.
And that's it for this episode of the EnVisioneering Exchange. Again, I'd like to thank my guests, Ted Wilke and Andrew Williams, for joining us. Don't forget to subscribe to the Engineering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get podcasts. And lastly, if you enjoyed this episode, please don't forget to rate, review, and share with your network. Again, my name is John Sheff, Danfoss' Director of Public and Industry Affairs, and we'll talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.